Lesson 35, angles and polygons, inscribed quadrilaterals, and fractional exponents. First thing that we're going to talk about is angles and polygons. Now just a couple rules to go over to review when we talk about angles and polygons. Right? We know a polygon is any geometrical enclosed shape made up of line segments. To find angles in a polygon, everything is based off of a triangle. Now we know first of all that the sum of interior angles in a triangle is 180 degrees. All right, the sum of interior angles in the triangle is 180 degrees. Every other polygon will be based off of a triangle. All right, for example, a quadrilateral. Okay, quadrilateral is a four-sided figure. All right, if we divide it into triangular sections, and each triangle is 180, all right, a quadrilateral has a total of 360 degrees. All right, if we look at a pentagon, all right, a pentagon is a five-sided figure. If we divide the figure so that we have triangles, and each triangle is 180 degrees, then a pentagon has a total of 540 degrees. All right, and we can continue this for any kind of quadrilateral. All right, so to find the sum of interior angles of a polygon, divide the polygon into triangles. And multiply the number of triangles by 180 degrees. Just as we did over here with the quadrilateral and the pentagon. All right, the quadrilateral was divided into two triangles. Okay, 2 times 180 gives me 360. The pentagon was divided into three triangles. 3 times 180 is 540. All right, you could do the same with a hexagon, with an octagon, all the way up through. All right, divide the shape into triangles, multiply the number of triangles by 180. All right, to find the exterior angles of a polygon. All right, now this goes true for any polygon. The sum of exterior angles of any polygon is 360 degrees. So it doesn't matter if it's a quadrilateral, if it's a pentagon, if it's a dodecagon, the sum of exterior angles, that's angles outside the shape, is 360 degrees. All right, the sum of exterior angles of any polygon is 360 degrees. All right. When we say exterior angles, we're talking if these sides were extended, all right, these angles would be the exterior angles. All right, and the sum of any exterior angles of a polygon is 360 degrees. Let's look at an example of this. All right, we have a polygon. All right, it has 1, 2, 3, 4, 5, 6 sides, which makes it a hexagon. Okay, it's an irregular hexagon. But the sum of exterior angles, this angle, here, 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 and here, all right, the sum of these angles should be equal to 360 degrees. All right, so in this particular hexagon, we are going to find, we're going to solve for x and y. Okay, x is one of the exterior angles, and y is the interior angle. All right, so to do that, we need to remember that the sum of any exterior angles of a triangle is equal to 360 degrees. So if I was to add all of these angles together, it should equal 360. All right, so let's set up an equation so that we can do that. We've got 80 plus 40 plus 50 plus 65 plus x plus 55 is equal to 360. All right, if we combine like terms, 80 plus 40 plus 50 plus 65 plus 55 is 290, and x plus x is 2x. All right, so we have 290 plus 2x equals 360. Subtract 290 from both sides. We're left with 2x is equal to 70, which means that x is equal to 35. All right, so this angle here is 35 degrees, which means that this angle here is 35 plus 55, which is going to be 90 degrees. All right, and we can use that information to solve for y. All right, if we look at the relationship of this angle that we just solved for and y, together they make a straight angle, which is 180. All right, so we have y plus 90 equals 180, which means that y is 90 degrees. Okay, so that is the sum of exterior angles. Let's next talk about inscribed quadrilaterals. Now, an inscribed quadrilateral is a quadrilateral or a four-sided figure inscribed in a circle. All right, here's the rule. If a quadrilateral is inscribed in a circle, the sum of the measures of any pair of opposite angles is 180 degrees. All right, so if a quadrilateral is inscribed in a circle, any pair of opposite angles together equal 180 degrees. All right, so if we look at our triangle, we're going to solve for x, y, and z. All right, if we're looking for interior angles first, all right, the sum of any pair of opposite angles together is 180. All right, opposite would be ones that are in opposite corners. All right, so we have 80 degrees and we have x. Those two together should equal 180. Okay, so we have 80 plus x equals 180, which means that x equals 100 degrees. All right, if we look at another pair of opposite angles, we have y and 75. All right, this means that y plus 75 equals 180 degrees, which means that y is 105 degrees. All right, so we have solved for x and y. Now let's look at z. All right, z is an arc. And remember, we've already talked about arcs previously. All right, but any angle that opens up to an arc, remember the angle is half of the arc. So this arc is equal to twice the angle. All right, well this whole arc is z and 50. All right, so we can make an equation from this that z plus 50 is going to be equal to twice the angle, or 2 times 80. All right, well 2 times 80 is 160. We subtract 50 to get that z is equal to 110 degrees. All right, and that's based on previous information that angles inscribed in a circle open up to their arcs. All right. Finally, let's talk about fractional exponents. All right, fractional exponents. Fractional exponents is a number that has an exponent that is a fraction. All right, so let's do 16 to the 3/2. When we have a fractional exponent, okay, we can rewrite it so that the numerator is the power and the denominator is the root. All right, so going back to our example, 16 to the 3/2. All right, the numerator is the power. All right, so we're taking 16 and we're raising it to the 3rd power. Okay, and the denominator is the root, so we are taking the square root. All right, so we're doing the square root of 16 cubed. Now, you can solve for this either way. You can do 16 cubed and find the square root of that. You can find the square root of 16 and cube it. All right, let's do the square root of 16 and then cube it. The square root of 16 is 4, and 4 cubed is 64. All right, so we have simplified 16 to the 3/2. All right, the numerator becomes the power, the denominator becomes the root. All right, let's look at another one. We've got negative 27 to the negative 1/3. Now, remember, when you have a negative exponent, to make it positive, you put it over 1. So this is 1/27 to the 1/3. All right? The numerator is the power, the denominator is the root. So we are taking 1/27 and raising it to the 1st power, and we are cube rooting it. All right? 1 is the power, 3 is the root. All right, and it's negative. Okay, so our answer is going to be negative. The 1 to the 1st power is 1. The cube root of 1 is 1. 27 to the 1st power is 27. 27 cubed is 3. Right? So we get negative 1/3. All right, let's try one more. We've got 4 to the negative 1/2. All right, again, first thing that we want to do is take a positive exponent. All right, so this becomes 4 to the 1/2. 1/4 to the 1/2, excuse me, we'll put it under 1. All right, now remember, the numerator becomes the power, the denominator becomes the root. So we're taking 1/4 to the 1st power and square rooting it. All right, so 1 to the 1st is 1, and the square root of 1 is 1. 4 to the 1st is 4, and the square root of 4 is 2. All right, so we get 1/2. All right, go ahead and try this one on your own. We have 8 to the negative 2/3. All right, remember to make it a positive exponent. All right, and then the numerator becomes the power, the denominator becomes the root. Go ahead and try that one on your own, and we will check it when we come back into class.